all you have to do, if your center is at h comma k, I don't know, they want our attention. They need you in the 11th grade office. Jake?
You need me there?
Yeah. Okay. So, if we label the center of our circle, and we label those coordinates with x, y as h comma k, then we plug that into the equation here to have x minus h in parentheses squared plus y minus k in parentheses squared equals r, which is the radius, squared. This is your standard equation. Just like, remember, for a linear equation, a linear line, it's just y equals mx plus b. You know your m is your slope, your b is your y-intercept. Okay, this is a similar to standard equation where if you write it like this, h comma k gives you your center, and r here gives you your radius. Okay, so it's just a standard formula that you need to know. You can copy this formula down into your blue books. I suggest you do whenever we finish notes today, and what all of those letters mean, what h and k mean, what r means. But we're going to use this in example 1. So if we're given the center of a circle and the radius, we can write an equation. So if our center is 2, -1, then we're going to write our equation here. We have x minus h, so for h, remember this is h comma k. So for h we're going to put in 2, so x minus 2 squared plus, and then in parentheses again, y minus k squared. So here our k is -1, so we're going to have y minus -1, and that equals r squared. So if our radius here is 3, that equals 3 squared. Okay. Now, we could leave it like that, but we could simplify this. It's a little bit messy. X minus 2 squared, that's fine, bless you. But do we want y minus -1? There's a simpler way to put that. Y plus 1. Okay, so I'm going to rewrite this as x minus 2 in parentheses squared plus y plus 1 squared equals 3 squared, which is 9. Okay, questions on number 1?
So that's all we have to do.
That's all you have to do there. If you're given the center and you're given the radius, you can just plug them into that formula. And you can leave your formula like this. That's standard. Okay? Alright, so now we're going to work the other way. In our next example, we're given the formula, and it wants us to graph it. So in order to graph it, we need to find the center, and we need to find the radius. Those are the two things that we need to find in order to graph it. So to find our center, we know our center we can write as the coordinate h comma k. And if you think about what the standard equation looks like, it's x minus h squared plus y minus k squared. So what would you plug in for h there? Or what is the value of h in our equation? It's 1. And is it positive or -1? It's positive 1 because we have x minus h, x minus 1. So h is a positive 1. And what about k? What could we plug in for k here? 0, exactly. So our center is going to be at 1, 0. So you can plot that on your graph. So go over 1 and up 0. So here is my center. And next thing, what's the second thing I said we needed to find to graph it? The radius. The two things you need to graph a circle is a center and a radius. Okay? So our radius, remember in our equation, this equals r squared. If over here I have it equals 25, to find r, what's the square root of 25? 5. So my radius, since r squared equals 25, my radius just has to be 5. Any questions about how I got that? Alright, so how do we graph this now? How do you know what the circle looks like? If we know our center, we know our radius is 5, we can go 5 units in any direction from our center, right? And that should give us the edge of the circle. So go 5 units to the right, draw a point, go 5 units up, draw a point, 5 units to the left, and 5 units down. Okay, so each of those, okay, I know that my radius is 5, right? Okay, so I know that if this is the center of my circle, the distance from the outside of my circle to the center has to be 5. So I can count over 5. That gives me a radius of 5. I can also go left 5. That's another radius. I can go down 5 and I can go up 5. I can go 5 in any direction and draw a radius. Okay. Other questions about how I got that? Right, once I know those 4 points, you can kind of estimate what your circle would look like going through all 4 of those. It's not going to be perfect, that's okay. But it should go through all 4 of those points. If you go up, down, left, or right, 5, you can estimate what your circle looks like. Other questions on second example? All right, next page. Okay, so here it just wants us to give the center and the radius for each of these examples. I'm going to put my standard equation up here. It's x minus h squared plus y minus k squared equals 1. Equals, no, what's it equal? Not 1. Radius squared, r squared. Right? So this just wants you to realize that in our generic standard formula, it's minus h and minus k. So in the first example, is my h going to be negative 3 or positive 3? Okay? If I have x minus h, what can I plug in for h here that's going to give me x minus 3? Think. If I plug in negative 3, I would get x minus negative 3, which would give me x plus 3. Is that what I want? No, so I just plug in 3. So, whatever it looks like is in here for h, it's going to be the opposite. So think of h and k, they're lined. It's going to be the opposite sign of what it looks like. So here our center is going to be at positive 3 for h and negative 2 for k. On the second one, what's our center going to be at? Negative 3, positive 2, just the opposite of what it looks like. The third one, it will be at negative 3, negative 2. And the last one will be positive 3, positive 2. Okay? So this just wants you to see that whatever it looks like h and k is, you have to do the opposite sign. Wait, what's our radius going to be in each one of these? What squared gives us 1? What times what? Or what times itself equals 1? Just 1. So our radius on all of these is 1. Should have made those more challenging. Okay. But questions about the sign of h and k. It can be a little confusing, so make sure you watch out for if it's positive or negative. Alright, you with us? You have your notes out? Okay. Okay, our last example for today. So, it wants us to write the equation of a circle whose center is at 1, 2, and 4, 6 is on the circle. Okay, well we know the center is right here, but what else do we need in order to fill in the equation of our circle? We need the center, HK, but what else do we need? The radius. Do we know the radius? No. But we know what's the definition of a radius. What is a radius? It goes half the distance across the circle, right? So it's the distance from the center to the edge of the circle. we know the center point and we know a point on the edge of the circle. So we can find the distance between those 2 points. How do we find the distance between 2 points? You might have to think back a little bit. Okay? So there is a formula for distance. You can write this down. Have you guys done this formula before, the distance formula? Okay, so it's d equals, and the square root of, and I want to make sure I'm writing this down right, the square root of, and it's x2 minus x1 squared plus y2 minus y1 squared. Now I'm second guessing myself. Looks right? Yeah. Okay? So we can plug in our points here using the center and the outside, because if you think about a circle, I'm just going to draw a little circle here. The radius is the distance from the center to any point on the outside. So if we know our center point's coordinates and we know the point on the circle, we can use those to find the radius, to find that distance. Okay? So I'm going to plug in 1, 2 for x1, y1, and I'm going to use 4, 6 for x2, y2. So when I plug those in, I'll have the square root of x2 is 4 minus 1 plus, for y2, I have 6 minus 2. Okay, so I need to do what's inside parentheses first and then square that. So I'll have all of this is square rooted. 4 minus 1 is 3, so 3 squared plus 6 minus 2 is 4, so 4 squared. Again, I want to do everything inside the square root first and then square root last. So 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. What's the square root of 25? 5. Okay? So that distance between the center point and that point on the outside of the circle, or on the edge of the circle, gives me my radius. So therefore my radius must also be 5. If you were given a graph, you could just count the radius, right? Since we didn't have a graph, we had to calculate it using that distance formula.
I thought the radius was like, or the diameter was radius times 2.
It is. You're right. That D represents distance, not diameter. This is the distance formula between 2 points on a graph. Yeah, that's a good distinction. This is the distance, not the diameter. Yeah. Alright, so here the diameter would be 10. 5 times 2. Okay, so we're not quite finished. We need to put this into the standard equation of our circle. So I have x minus h. Again, our center here is at 1, 2, so h is 1. So x minus 1 squared plus y minus, my k here is 2, so y minus 2 squared equals my radius squared, so 5 squared is 25. So there's my equation. Simple to plug it into that equation, but you might be asked to find the radius or find the center. Okay? Questions?